Afternoon, ma'am.
Just wait. Division 6 will also join along with you. Anybody from Division 6, have you joined?
Yes, ma'am. Good afternoon, ma'am.
Good afternoon. Okay. Just couple of minutes. I'll give Division 6 students to join. Then we will start. Division 6, what has happened? How many Div 6 students are there? Have you all joined? Is the CR there? How many students from Division 6 have joined? Just put up the hand icon.
Ma'am, from Division 6, just now sir left, so please give us 2 minutes.
Okay. No issue.
Thank you so much, ma'am.
Excuse me, ma'am.
Yes, Mansi, speak.
Ma'am, we are sorry. Actually, Anand Pandya sir was continuing some equations, therefore we were late.
ठीक है. Okay, yeah. Tell them to join fast, okay?
Thank you, ma'am.
Yeah. What is that question in the chat? CT will be online or offline? Okay, we don't know actually, Jai. As of now, we don't have any information regarding class test. Okay, only the timetable we have received, but how it will be that we don't know whether online or offline. Okay. Division 6 students, have you joined the class?
Yes, ma'am.
Yeah, okay.
Yes, ma'am.
All right, fine. So we'll get started now. So last time we had started with orthogonal trajectories in both the divisions, right? Now just I'll bring up the PPT and you just tell me up to which point we have completed, okay? Let me just start from the beginning itself. Just to confirm it, up to which point we have finished. See, we finished definition in both the divisions, right? Then after that,
No, ma'am.
who is saying no? Who is saying no? In my records, it is all written. Here I'll be asking you just for the, courtesy like. But actually I'm having everything in my record. So definition is finished in both the divisions. I know that. Okay. Yes. So just to tell me which problem we had finished. That much only you tell me. Which example we had completed. This procedure also both the divisions have written down.
Yes, miss.
You have written down the procedure in Cartesian form as well as in polar form. Right or wrong?
Yes, miss.
Yes. Okay. Then one example have we done? Numerical 1 is completed. This is in which division? Division 2. Division 6. Division 6. Which numerical we have completed? Okay, in division 6, one numerical. What about division 2? Division 2.
4x.
Huh? Y square is equal to 4ax. That is completed, no, in both the divisions?
Yes, miss.
Okay, very good. Yes, very good. Okay. So we have in both the divisions, we have not done the numerical in the polar form. Is that correct? What I'm saying?
Yes, yes, ma'am.
Okay, fine. So everybody, what to do? First of all, you just write down this question. So now we are doing the example of finding out the orthogonal trajectory in polar form. So write down the question. Find the orthogonal trajectories of the family of cardioids. R is equal to 8 times 1 plus cos theta, where A is the parameter. First, you note down the question. Then we are going to follow the theoretical procedure. So whatever is described in the theory, that same thing we are going to do over here while solving the sum. So it should take you about a minute or something to just note down the question.
Done, ma'am.
Okay. Okay, so now let us start the procedure. So first we have to form the differential equation. So here you can see on the screen, first differentiation has been done with respect to theta. And now we are going to eliminate this A from 1 and 2, isn't it? By substituting. So the value of A you will substitute from this. Okay, so from here you will get A is equal to minus 1 divided by sine theta into dr by d theta. This you will substitute in this equation 1 and here in this equation 1, and then you will get this equation 3, which is the required differential equation. Okay, so step 1, 2 has been completed. Now this is step 3. replace dr by d theta by minus r square d theta by dr. So much you can just note. Have you followed what all has been done? Are you understanding? Students, are you
Yes, miss.
understanding what is done? First we differentiated, we got rid of this a, then we put the substituted this value of a in equation 1, then we got the differential equation. So step 1 and 2 we have completed. Now step 3 we are replacing dr by d theta by minus r square d theta by dr. Why we are replacing? Because the two slopes, okay, when they are multiplied, they are equal to -1. That means the two curves are intersecting each other at 90 degrees. So therefore, we are doing this replacement, right? Okay. So you write down so much, then we will continue.
Ma'am, why we are replacing this?
Because I told you, know, what is the definition of orthogonal trajectory? Tell me, beta, tell the definition. Who has asked this question? What is orthogonal trajectory? What is orthogonal trajectory? Tell the definition first. Whoever asked this question, I want to answer you, but first you have to answer my basic question. Definition of orthogonal trajectory. No, not willing to answer. Okay, then leave it. You must also respond, no, when I ask you something. Just like that one-sided, you cannot ask me one question and stop. First, you have to answer what I've asked you. What is meant by orthogonal trajectory? Who is Anurag Mukwane?
I don't remember.
No, you don't remember. I refer to your notebook, Sahil Jagtap.
Ma'am,
No, Sahil Jagtap, wait a minute. Sahil Jagtap, you refer to your notebook and tell the definition.
Yes.
I don't remember is not the response which I will want from you. Okay. You have to refer to the notebook and tell me the answer. Because already we have done. Who is Anurag Mukwane? Anurag Mukwane.
Ma'am, he's a cadre from Division 6.
So where is he? He should unmute and speak, no? Anurag Mukwane, please unmute. Who is Anurag Mukwane? Tell him to rename himself with his IMU ID number. I'll put him in the waiting room. Friend can tell. Friend of Anurag Mukwane, tell him he has to rename himself with the IMU ID number and then join the class again. See, we have established one protocol, no, of how to attend the lectures, isn't it? So accordingly, you have to attend. So tell whoever is a friend of Anurag Mukwane, tell him to rename himself with IMU ID number and then join. Acha, yes, Sahil Jagtap, I'm waiting for your answer. Definition of orthogonal trajectory. If you're not going to answer, then I will not be interested in answering your question. Okay, students, let us continue. So we will continue. After replacing, we are going to get this new differential equation. Okay. Now what we do, we are going to use our one of the methods of solving this new differential equation, right? So here I have done the substitution and everything you can see. And of course, here we can solve by using variable separable method, right? So already we have done the integration and everything. Here I have written the results also, which are being used for doing this integration. So you can just take down the integration part. It is easy. You can attempt on your own also. And you can write down the final answer, which is the answer to the question. What Anurag Mukwane is not interested in renaming himself. That means he is not actually in the class. He doesn't know what is happening here. He has gone to sleep. Probably is not responding to the friend. Who is the roommate? Any roommate of Anurag is there in the class?
Actually, ma'am, I am changing my name, but it's showing error. So please give me some time.
Who you are? Krish Jaiswal? No, why you are changing your name? Yours, everything is correct.
No. Actually, I am Anurag, ma'am. I am speaking from Krish ID. He's with me.
Acha, okay.
Just give me a second, ma'am.
All right, all right. Okay, so I think this is variable separable. Easily you can understand the integral which you have to solve also. It is a very easy one, nothing complicated. So all the steps I've written over there, you can just note down. And this last equation, it is going to give you the equation of the required orthogonal trajectories. So we can see that we were given a cardioid, and this equation which we have got, that is also the equation of the cardioid, right? So if we just draw one, if I draw one rough sketch, so first equation, right? This is the figure of a cardioid. And then second one, okay, somewhat like a heart-shaped figure this is. Here this point of intersection is going to be 90 degrees, intersecting at 90.
Ma'am, you are going to share these notes.
Huh? What is happening?
You are going to share these notes, all of these slides.
I will be sharing, but you have to note down in the notebook. Getting it or what?
Yes, ma'am.
Just because see, that is why initially I don't like to share, because otherwise then the students, they don't write properly in the notebook what I've observed. So that is why, first of all, it is better that you write down in the notebook. Then afterwards I will share. Okay, first you have to understand that sharing is a small matter. Acha, this integral and everything, everybody has understood and written or what? Sahil Jagtap never answered me only orthogonal trajectory. That means he has not made the notes properly. This shows that. Okay. No, you will make the notes. Nahi. Just now, what about the answer to your question? Unless you know what is orthogonal trajectory, I will not be able to answer that question which you have asked. That is the dependency. That is, I asked you first to define orthogonal trajectory. Then so far, how you were attending the lectures? This way it will be very difficult, cadets. You should attend the class properly. Okay, now has everybody written down the equation and everything properly? Is the procedure understood by you? Tell, first of all, both the students. Have you understood the procedure of finding out the orthogonal trajectory in Cartesian and polar form? Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay, so now I will give you one example. You solve it, okay? See, now these are for practice. You note them, but this first one you solve now in the classroom. Just now only you solve it. X square minus y square is equal to C. This one you do it in class right now. I will open up one first to note down this. I'll give 2 minutes to everybody to note down this. Then I will open up a new screen. Then you all are going to tell me all the steps. Whatever you are telling me, that I'm going to write on the screen.
Solved, ma'am.
Very good. Okay, now, so what I'll do, I'll just open up the screen. News, and you are going to tell me the steps. So x square minus y square is equal to c. We will call this equation 1. Okay, next step, tell me what I have to write.
Ma'am, 2x minus 2y dy by dx. Equal to
2x minus 2y dy by dx is equal to
0.
0. Okay, so this is equation 2. Now finished. We have eliminated c, isn't it? There is no c. So now what we have to do? Next step.
Ma'am, replace dy by dx by minus dx by dy.
Minus dx by dy, correct. Is equal to 0, right? So what will happen? 2x plus 2y
dx by dy.
dx by dy is equal to 0. Now how we are going to do? How we are going to solve this?
And variable separation.
Variable separable. So how I should write this? Just tell me. 2 and 2 will get cancelled. So dx upon x, okay, is equal to, or you can do dy upon y, whichever. All right, we'll do dy upon y. Whichever way is okay, fine. So dy upon y is equal to, how I should write? Minus dx upon
minus
x.
dx by x.
And now we can integrate this. Now after integrating, what you will get? Log y is equal to minus log x plus what I should write? Log
Plus
c.
Log
C, because then we can get rid of the. So now this I will just write it as, now this is log c minus x. So how we will write? C upon x, isn't it? Log of a upon b is log a minus log b. So like that way, and this side of course log. So now we are going to take off the log on both the sides. And now we can write xy equals to c, and that is the equation of the orthogonal trajectory. Got it out? Students, got it?
Yes, ma'am.
All right, very good. Okay, so that means.
Ma'am, can you explain the last 5 question, 5 number, y equal to x minus y plus c e to the power minus x?
Which one? Why
Ma'am,
is
you
it?
have even given a practice question number 5.
Okay, 1 minute. Just one, give me a minute. Okay, which this question number 5 or what?
Yes, ma'am, 5, ma'am.
What do you want me to tell you in this? What I should tell you means?
Ma'am, replacing a step after that, I am not able to proceed.
That you can do for homework right now. You don't have to solve immediately. You give it a try, no? First you do all the things. Means you are not able to solve the differential equation. Like this way you're telling me, isn't it?
Yes, ma'am. Yes.
So you have to try that. Okay, right now you may not get the answer. It is all right. Give it a try. Discuss with your friends also. Isn't it? All these things you have to do. See, whenever you are learning something, learning doesn't mean only in the classroom you have to learn the things. Like that also you have to learn. Sometimes when the teacher gives you something for homework, you try to have discussions amongst yourself also. So can you discuss with your friends? Who is your roommate?
Yes, ma'am. I will discuss, ma'am.
Try to discuss and see who gets the solution. Let us see how many of you solve. Just now don't solve everything. Now we are moving to the next point. Okay, now one application we have finished. That is orthogonal trajectories. Now second is going to be the application related to the simple electric circuits. Now in electric circuits, everybody has got the basic knowledge already. So just I'm revising all this. So there are some elements in the circuit. They are called active element and passive elements. Now passive elements are resistance, inductance, capacitance. Active element is the voltage source. That can be either a battery or a generator. Now here the symbols are given for all these elements. Okay, so see which are the required ones: quantity of electricity, current, okay, then resistance, inductance, capacitance, symbol as well as the unit for each of these is given. Are you familiar with all these things? Students, yes, from your basic electricity, everybody knows all these things, right? Yes or no? Already you have studied it in the earlier class as well as now also you are studying everything. Okay, even in the previous semester also you have done these things. So this you need not write. However, the basic relations, maybe some of you may or may not recall. You may recall this. Current is rate of flow of the charge. Then voltage drop across resistance R is Ri. Then voltage drop across inductance L is L into di by dt. Then voltage drop across capacitance is C upon Q. All this you can note it. This you may or may not recall. So you just note all these things. Have you noted down?
Ma'am, just 1 minute.
Hmm.
Yes, ma'am.
Yeah, okay, fine. All right, now next is the Kirchhoff's laws. Can anybody recollect? I'm also going to tell you. So again and again, Jaishil, you are only bothered about the CT. You are not bothered about what is happening in this class. It appears. How many times you are going to ask me the same question? So again, I will give you the same answer that we don't know whether CT is going to be offline or online. We don't know. That is the answer to your question. As of now, we know only that your CT is there on 21st of March. Jaishil, unmute and answer. Have I answered your question? Jaishil, 137. Unmute. Yes, Jaishil. Where is Jaishil? Tell him to unmute. Who's room partner? Who is the roommate? We don't know anything about the nature of the paper. We don't know anything. Now he ran away in the waiting room. Once I told him to unmute. So all the students, I'm telling you all, we don't know anything about the nature. Offline, online, we don't know anything. Only we know that the maths paper, it is on 21st. That's all we know. Okay, once we come to know that time, you will get the official information only from the concerned department. Okay, will not individually inform you because nature will be same only for all the subjects, most likely. So you will get official information. Okay, Kirchhoff's laws, I've asked you. Just tell me Kirchhoff's laws. Kirchhoff's laws.
Outflow voltage is equal to the inflow voltage, and sum of current is 0.
No, that first law you're not telling properly. Just you think little and answer properly. See, there are two laws. One relates to the voltage, one relates to the current, isn't it?
Yes, on KCL and KVL.
So KCR and KVR. So KCR is okay, kind of, you have told, but KVR. Okay, just even if
The
you don't
voltage-
remember, you take down. No, take
voltage-
down now. See the screen and take down the algebraic sum of the voltage drops around any closed circuit is equal to the resultant electromotive force in the circuit. That is the first law. And the second law is the algebraic sum of the currents flowing into or from any node is 0. That is the second law. Okay, so both these laws you take down, because sometimes while solving the sums, we will require to make use of these Kirchhoff's laws. Jaishil Patel, just unmute yourself. Who is Jaishil Patel?
Sorry, ma'am. Ma'am, I was disconnected due to network error.
ठीक है. Your question has been answered or what? What I
Yes,
told you?
ma'am. Yes, ma'am.
So I don't know. Nobody knows as of now. Whenever we will get the official notification, that time we will tell you. Got it?
Ma'am, I was asking because there were rumors around.
No,
someone-
I don't operate on rumors. Okay, I operate on the basis of the official notices. Got it or what?
Okay, ma'am. Thank you. Sorry, ma'am.
Yeah. So whenever the official notice comes, that will be the one. Rumor, what? Rumor will go on like that only. What is the point of that rumor? Okay, nobody has time here to deal with rumoring. So you also wait. In the meantime, you can start studying, isn't it? That is in your hands. You study, whether it is offline, online, whatever it is, you start studying. Got the idea? All of you. You have to study for the test and appear for it in whichever mode it is, isn't it? That is going to be your job. So you start your studies. That's why I'm telling you, attend the lectures properly. Okay, students. One fine day, otherwise you will come to know that the whole semester got converted to offline. And if the semester gets converted to offline, then obviously end sem exam also, probability of end sem exam also being offline is going to be then very, very high. So be prepared for all the things. So you start studying and start attending the lectures properly, whether online, offline, whatever it is. Okay, now these are the two Kirchhoff's laws. Now we will see the application. Take down the problem statement first of all. This is the problem statement. Problem statement is noted. because I'm going to open a new screen and there I'm going to solve the sum.
Ma'am, just a second.
Yeah.
Yes, ma'am.
Okay. Okay, so question is noted. Now just look at the screen. See, first of all, let us see what all you have been given. So you have been shown that the differential equation for the current I. So which elements are given to you? Current I, okay. In an electrical circuit containing an inductance cell, all right. So inductance cell is given to you and resistance R, okay. In series, all this is connected, right? By an electromotive force E sine omega t. So electromotive force is E sine omega t, and that is what it satisfies the differential equation. Okay, yeah, all right. So over here, so we are going to use our basic concepts now. See, first of all, what is the Kirchhoff's first law? State it. KVR. Just now only we have seen. What does KVR say? KVR, students. Just now only I have given you and you have noted it.
The algebraic sum of voltage drops on any closed circuit.
Algebraic sum of the voltage drops around any closed circuit is equal to the resultant electromotive force in the circuit. So now we have current I, we have resistance, and we have this inductance. So now tell me, what is the voltage drop across the resistance? What is it? Tell me. Just now I've given you the formula R into I. What is the voltage drop across the inductance? What is it?
Di by dt.
Yes, L di by dt. So as per Kirchhoff's first law, voltage law, sum of these voltage drops, okay, is equal to the resultant electromotive force, which is E sine omega t in this case. So we have proved that this differential equation is satisfied. Got it or what? Students, got the idea? Yes or no? So see here, that is I told you that the basic concepts, all which you have learned in your electricity, those are important over here to do this application. So I used the basic definitions and this Kirchhoff's first law, and now I could prove this. Okay, now what we have to do? We have to find the value of the current, no, at any time t, if initially there is no current in the circuit. That means our question is find I. Okay, and the given condition is what? What is the condition? At t is equal to 0, value of I is 0. This is the initial condition, right? So initially no current is flowing through the system, so no time has elapsed. So that is why t is equal to 0, I is equal to 0. Now we have to solve this differential equation. So for finding the value of I. So now students, you just tell me which method you will use to solve this differential equation. So in mathematics, when we say application, we mean whatever we have learned that we are applying. So we learned different methods of solving differential equations, isn't it? Variable separable, reducible to variable separable. Then which one we learned? Linear, then Bernoulli's, then exact. So like this way we have learned all these different types. So out of that, which one do you think will be suitable for solving this and finding the current? Tell me. After looking at this, what is your opinion?
Ma'am, linear form.
Yes, very good. Linear form, correct. So linear form is given by dy by dx plus py equals to q. So here you can see that that is the best one for this type. So here we can just rewrite it like this: plus r upon L I is equal to E upon L sine omega t. And here you can just see that I is the dependent variable, t is the independent variable. So this r upon L will be p and this will be q. So this is p, this is q. And now what we can do, we can find out the integrating factor and all that. So integrating factor is equal to e raised to integration of r by L dt. So this is equal to e raised to RT by L. This is integrating factor. Now for the solution, dependent variable I into integrating factor e raised to RT by L is equal to integration of Q. So E upon L, okay, sine omega t into integrating factor, that is e raised to RT divided by L dt plus C. So we can take the constants outside the integration sign. So integration of e raised to RT by L into sine omega t dt plus C, like this way. Now for this integration, see there are two things. Either you can use integration by parts and then you can find out the integral value, or there is one formula. I don't know whether you are recalling it or not. E raised to x into sine bx dx, likewise even cos bx dx. So this formula you may be recalling, isn't it? I think so. You may be recalling. This is e raised to ax divided by root of a square plus b square into bracket. Yeah, anybody wishes to attempt? A sine bx minus b cos bx. Right. This is the formula. Maybe last semester you may have studied this formula. So you can use this and solve this integral. What, following something, students? Yes or no? Yeah, division 1,
Yes,
division
ma'am.
6. So see, if you remember this formula very fine, then you will proceed fast. If you don't remember that formula, but you are expected to remember it, because in electrical applications, many times we are coming across this e raised to something into sine or cos. So it is better that you get familiarized with that formula. But if you are not remembering it, then there will be no option. You have to do integration by parts and apply Eilert rule and everything. Okay, this much is noted by you, whatever is there on the screen. Have you noted it?
Yes.
Okay, I'll give you 1 minute. Done or what? Students, I'm waiting for you. Have you finished?
Yes, ma'am.
So here you just write e raised to RT by L into I is equal to, now what was our thing over there? E upon L, e raised to RT by L into sin omega t dt. Now you can use that formula and you can find the integral. So e upon L into e raised to RT by L divided by root of. So I'm just applying that formula. So in this case, you can see that A will be R by L and B will be omega. So that I'm using. So R by L minus like this way. All right. Now we are going to take all this constant and also E. Now L and L will get cancelled out. Okay. And here also we will cross multiply. See here we will just put R sin omega t minus L omega cos omega t, okay, divided by L like this way. Okay, so this will be your final answer. We are taking this E upon L and all that this way and writing, or you can leave it this way also. There is no issue. Now one plus C everywhere, plus C. Now one more step, because we have to find the value of the current. So I'm going to take e raised to RT by L to the right hand side. So I will write this way. So e raised to RT by L, it will get cancelled out. And here we'll have this way, okay, plus C into e raised to minus RT by L. So I have shifted that to the right hand side. Now at this stage, you can apply the initial conditions at t equal to 0, I is equal to 0. So you substitute. So 0 equals to, put the values. Sin omega t, sin 0 will be 0. So that will get cancelled out. Now cos omega t, if you put cos 0 will be 1. So you will be left with plus C into all that. So there e raised to 0, that will be 1. So you will be left with E into, so L and L will get cancelled. So E omega, okay, divided by minus, this will be minus E omega divided by R square plus L square omega square plus C. So this will give you the value of C, E omega divided by root of this R square plus L square omega square. So now for the last step, what you have to do, you will substitute this value of C in this equation, and that is going to be your final answer. So that last one step, you can just do it and you can complete it. So in this manner, we have found out the current at any time t. Okay, students, you can finish noting both the CRs. You all can give me the status of the attendance. What is the situation? Yeah, CRs. Division 2, who is the CR? Or you can WhatsApp me afterwards. Division 2 and division 6 also.
Yes, ma'am.
So that last step, you just complete it. You substitute the value of C in that equation and rewrite the equation. So that is all that is remaining. Okay, let me know when you finish. I'll leave the screen. Hello, Sujata madam, are you there? Hello. Hello, Sujata madam, are you there?
Yeah, ma'am, I'm there. Good afternoon, ma'am.
Good afternoon. I make you the host.
Fine. That's what I was saying.
NLE. Acha, students, you all have finished noting down all these things. Division 1 and 6.
Yes, ma'am.
Okay, fine. So I'll just stop sharing. Okay, madam, you are the host. Huh? Now I'll leave the meeting. Yeah.
Thank you, ma'am.
Okay, thank you.
Yeah. So I think div 2 is there, and another division is which one?
Ma'am, div 6. Ma'am, can we leave?
Div 6 can be. Yeah.
Thank you, ma'am.
Good afternoon, ma'am.
Good afternoon. Still, I can see 48. Yes, 46 students. So div 6 leave, and only div 2 cadets should be over here. Who is CR of division 2?
06 for Animesh.
06?
4.
You only. Animesh, you only, right?
Yes, ma'am.
Just check the participant list, and might be koi soya hoga division 6 ka. So you just tell me, I'll remove from this meeting.
Okay, ma'am.
Yeah.
Aurora and Jeshil Patel are of different division 6.
Sai?
Ma'am, Paksh Aurora and Jeshil Patel of division 6.
Please slightly louder. I'm not able to understand. You just tell me the number. You tell me the number of the cadet from division 6, and I'll remove that cadet. Acha, you're typing best. 129. Okay. Let me check.
159.
You have written 129 and 159 both, right?
193.
193 also. Okay. So I removed 129, then 159. Yeah. And 193. Fine. Now all are from div 34. Animesh, what is the strength?
34.
34. So one is absent or what?
Ma'am, might be he is joining.
He's joining. Let him join. Yeah, fine, no problem. Okay. So can anyone tell me what was the last thing that we did in your class? Yes. क्या था last? आपको track रखना ही पड़ेगा. हाँ बोलो. Yes, Sahil.
Effect of temperature.
We started with the temperature. Whether
Temperature coefficient of resistance metal.
Correct. So we did this relationship also. Alpha 2 in terms of alpha 1 and some more terms. We did this.
We did last one. RT is equals to R naught 1 plus alpha T.
Very correct. Okay. And both the things, na? Matlab RT2 and then RT1, and then we divided those two things. Am I right? Correct hai? Yes.
No, ma'am. We don't done them.
We have not done this. Okay, wait.
No,
Let
I'm
me
not
check.
done.
Wait, let me check that. Okay. So temperature coefficient of resistance we started and we did till this R naught 1 plus alpha T. Am I right now?
Yes, ma'am. Till then.
What is alpha? We that also we discussed. RT minus R naught divided by R naught T and definition of alpha. Am I right? Okay.
No.
If you are saying okay, if you are saying no, I will write that. No problem. I got where we were. So we tried to see temperature coefficient of resistance, and for metals we tried to see, and we came till the formula RT is equal to R naught 1 plus alpha T. Yeah, इस point तक हमने किया है, right? So very well we can write RT minus R naught alpha T. And very correctly we can write for alpha, that is RT minus R naught upon R naught T, right? Whatever will be the difference, whatever the temperature that you want to achieve from your initial temperature is 0 and the final temperature is T. We try to see that. And from this formula, very well we can write the definition of alpha. So how we can define alpha? It can be defined as increase in the resistance RT minus R naught per ohm original resistance per degree centigrade rise in the temperature, right? That will give you value of alpha or definition of alpha, we can say. So I'll write it. Alpha can be defined as increase in the temperature, increase in the resistance per ohm original resistance per degree centigrade rise in the temperature. Fine. So we try to get what is this alpha and how to get the temperature. If I know the alpha and we know that yes, it is going to depend upon the material of which the resistance is made up of, the substance that you are using for the same. Hai na? But till now, I think you did somewhere in your 11th or 12th also, you did this thing. And nahi kiya to very nicely, we tried to see in the last lecture from where we got this formula. Yes, all are with me.
Yes, ma'am.
Yeah, good. Right, so we know this thing. Now the next thing is, keep in your mind, even if we are saying this alpha is constant, right? It's not constant. There are slight changes in the value of alpha at different temperatures. Means if I'm saying at 0 degrees and if I'm marking or naming it as alpha naught, at T degree centigrade, when you are changing the temperature, you will find the alpha naught is not becoming remaining the same. It changes slightly. So it depends on the temperature also. In that case, what should be done? What it is, how to get the value of that, we want to know. Okay, so let us think of, right? I'll clear the board first and I'm writing. So value of alpha changes, or value of alpha at different temperatures, what it is. We want to see how to get the value of that, right? Practically, it has been observed that yes, alpha ka value changes as the temperature changes. Fine enough. So, chalo. So let us say we are talking about heating and cooling in between the same temperatures, and let us take a reference as same 0 degree. So initially while heating, so this is heating, this is cooling. Okay, and let us say initial condition for heating is A and final condition is B, And then when you are cooling, your initial condition will be B and final condition will be A. That's it. So for heating, the initial condition we are saying 0 degrees centigrade. So at that point, alpha ka value, let us say alpha naught, and resistance, let us say R naught. Okay. Now when you are heating, right, let us say it is reaching till T degrees centigrade. And let the alpha ka value at that point is alpha T. And let temperature to be R. So heating already we know how to go for it. Cooling ke liye the formula we are aware of, but how to apply the formula, we'll try to see that. Let us go for it. So I'm talking about first condition, that is heating. And now you'll observe that when we are talking about heating, initial is 0 and final is T. So we can write it as RT is equal to R naught. Final temperature is equal to initial temperature inside the bracket 1 plus whatever was the value of initial condition at initial temperature, and multiplied by the final temperature minus initial temperature, that is T minus 0. For simplicity, I'm writing it. Okay. So I can write the same thing as RT. I'll take this R naught inside. So R naught plus R naught alpha naught T. Correct. So I can write RT minus R naught as R naught alpha naught T. Right. So I will require this value. That's why I'm expanding the thing and writing. Acha. एक simplified value भी लिख के रखते हैं for the first condition. So I'll write RT also is equal to R naught 1 plus alpha naught T. Okay, let us say this is equation number 1 and this is the equation number 2, and we'll utilize these two things. Just a moment. So this is all about heating. Now what happens under cooling, we'll see. So I'm talking about cooling. When you are cooling the material, initial condition is B and the final condition is A. So final temperature is equal to the final resistance is equal to the initial resistance 1 plus initial resistance ka coefficient, that is alpha T, final temperature minus the initial temperature. Yes, all are with me. Is it okay?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yes. So it is going to be 1 minus alpha T. Now we'll expand. So you'll have R naught is equal to RT minus RT alpha T. I'll take this RT on this side, so it will be RT R naught minus RT. ये minus sign वहाँ पे absorb कर लेते हैं, तो you'll have RT minus R naught is equal to RT alpha T. So now I'll try to write alpha T. So alpha T is going to be RT minus R naught upon RT into T. Correct. So let us put the values which are available to us. So from first equation, you are having value of RT. So that RT ka value I'll put in the denominator. And from second one, you are having RT minus R naught. This value I'll put in the numerator. So you'll have R naught alpha naught T upon RT, that is R naught 1 plus alpha naught T and into this T. So this T will get cancelled out. This R naught will get cancelled out. And very well we can have, मैंने कुछ mistake किया, मैंने RT लिखना था, मैंने R naught लिखा, sorry, my mistake. I should write alpha T, है ना? So I can write alpha T is equal to alpha naught divided by 1 plus alpha naught T, whatever is the temperature difference that is there. Have you understood the relationship? Yes. Yeah, good enough. Now, why I am doing all these things? One thing is we may require this thing while solving the numericals. Second thing, IMU का paper है, might be this derivation will be asked, right? Calculate alpha at particular temperature T in terms of alpha at 0 degree centigrade. So you should be aware of the derivation. है ना? 2-3 mark के लिए can be asked this thing. Now, we are talking about at 0 degree centigrade alpha naught. But might be both the things here are starting at different temperature only. That means from 20 degrees to 60 degrees you are going without talking about the initial alpha at 0 degree centigrade. Then the generalized thing also should be with you. Always in terms of alpha will be a problem. Alpha naught will be a problem. So we can write in general. If we are saying alpha 1, right, temperature coefficient at T1 degree centigrade and alpha 2 is the temperature coefficient at T1 degree centigrade. Okay, so very well we can write alpha 2 is equal to alpha 1 upon 1 plus alpha 1, and now we have to say मैंने mistake किया हुआ है, I don't know. T2. Okay, so this will be alpha 1 delta T. Difference in these two temperatures. Previously what was reference was 0. So that's why it was T minus 0 only T. But now, yeah, you should consider difference in these two temperatures. So it will be T2 minus T1 that we are representing it as delta T. Is it okay, everyone? Yes?
Yes, ma'am.
Good, good. Chalo. Then the next point is one more point we should discuss, which will require for solving the numericals. Let us say one condition of T2 and just मैंने यहाँ पे लिखा है ना, and we are talking with reference to 0 only. So I can write it as R2 is equal to R0 1 plus alpha naught T2 minus 0. So it will be T2. At T2, the resistance of that particular material or metal is R2, we are saying. And अगर कुछ different temperature है, let us say T1 है, तो resistance will be R1, some values will be there. So it is going to be R0 1 plus alpha naught T1. Now without knowing the value of R0, but we are aware of value of alpha naught, very well we can write the thing as R2 by R1 is equal to 1 plus alpha naught T2 upon 1 plus alpha naught T1. So we divided these two equations and R naught is getting cancelled out. So whatever I'm putting in the block, try to remember, try to enlist all these formulas. Chalo, I have written all the formulas. Now any of you, any query, any doubt for this? Otherwise we'll start with the numericals. Very simple. Is it okay? Okay with everyone?
Yes, ma'am.
ये एक भरत है, एक हर्ष है, गुड, एंड एक इंद्रजीत है ना? हाँ, ये तीन ही लोग मुझसे बात करेंगे, बाकियों को कुछ लेना देना है नहीं क्या? ओके, नहीं है, लेना देना नहीं है. ओके, कैन आई क्लियर द बोर्ड? यस?
Yes, ma'am. No, ma'am. No, ma'am. No, ma'am. No, ma'am.
Okay, okay, fine. Manthan is there. Manthan, I'll save this and you tell me, I'll wait for you, huh?
Yes, ma'am.
Yeah, okay. Then we'll start with the numericals.
Yes, ma'am. Done. Thank you.
Done? Okay, sure. So clear. And now we are solving the third numerical. Okay. Two numericals already we did in the starting. Now I'm talking about numerical number 3. And just last time here, the same thing I'm going to do. I want you to note down the numerical, find out the answer. I'll wait for you for 3-4 minutes. Put your answer in the chat box. Don't share it with everyone, right? And after 3-4 minutes, whatever, 4-5 log to I know they will solve it. And if it is correct, I'll put it in the chat box, correct or whatever, comment. And then after 5 minutes, I'll solve. What happens because of that? If you'll give your correct answer in between, no, वो जो interest है ना solve करने का बाकियों के लिए वो चला जाएगा. So I don't want that to happen, right? So I want you to solve it and type your answer, put your answer in the chat box. That's it. It is found that the resistance of a coil of wire increases from 40 ohm at 15 degrees centigrade to 50 ohm at 60 degrees centigrade. Calculate the resistance temperature coefficient at 0 degrees centigrade of the conductor material. Chalo, solve it and put your answer in the chat box. I'm waiting.
ये तो प्यार है.
Hi, Naraji.
Ma'am, your heart is disturbing.
Dev. It's wrong. Check it once. Good that you tried to solve, but you made some mistake. I don't know what it is. Check it once.
Ma'am, 1/135.
Bharat, what I said, you type in the chat box. Why you are telling your answer over here? Dev, now it's correct. But one more suggestion will be for you. Whenever it's a single number and it's in decimal points, no? Ha, Bharat, correct. You try to write the next digits also. So
Okay, ma'am.
whatever you have, ठीक है. One answer, two answers I got correct. Asile is wrong. No, Jatin, is not negative. So I got 4 answers. 2 are correct, 2 are wrong. Fine. No worries. You are trying to solve. That is a very good thing. Some more answers I want over here. बाकी के क्या कर रहे? सोए हैं. Yeah. Now still your decimal point you tried to put, that is wrong. Side.
Yes, ma'am.
Yes, side.
I am getting 0.06.
I can see that thing, but that is wrong. That's what I said. Okay, I think I should itna time nahi lenge. So yeah, first thing is given that 40 ohm at 15. So I'll write R1 as 40 ohm and the temperature for that particular resistance, it is at T1. T1. Actually, R1 nahi bolenge, RT1. Normally, we used to say RT1. That's why I'm saying RT. Na? You may say R1, R2, whatever you want to say. RT1 as 40 ohm at T1 equal to 15 degrees centigrade. Fine. Then second condition is given RT2 is equal to 50 ohm and at that point the temperature is 60. And we know one formula just now we had seen. RT1 upon RT2 is equal to 1 plus alpha naught T1 upon 1 plus alpha naught T2. And what is asked to you? Calculate the alpha naught only. So good enough. We are on the right track. Hai na? So it is 40 by 50 is equal to 1 plus alpha naught 15 and 1 plus alpha naught 60. Correct? So let us cross multiply. 40 plus 2400 alpha naught 1 मतलब 50 plus 750 alpha naught. बस अभी आपको subtraction करके divide करना है and done. So what I can write? I can say 2400 minus 750 कितना होता है?
1650.
1650. Correct. Alpha naught is equal to 10 and alpha naught you can write it as 1 upon 165. मैंने 0 cancel out कर दिया per degree centigrade. Now some of you are trying to convert it into decimal. Fine, it is 0.0006. 0.006060. Fine, per degree centigrade. Both the answers are correct. है ना Sahil? There is slight shift in your answer. I don't know how come.
Yes, ma'am. Yes.
Yeah. Is it okay, everyone? Yes.
Yes, ma'am.
Yeah. Okay. Okay, now we'll go for the second one. Yeah, numerical 4. An armature has. क्या problem है इंद्रजीत? Who is sitting with you?
मैम ये हर्ष मैम डिस्टर्ब कर रहा है मेरे लैपटॉप
I know. Who Harsh or what? I'll mark his absent. Very simple. He's from which division? Your division only?
4 division.
Wow, ये क्या नौटंकी है? He is not having his class. Or you unmute yourself, Indrajit. हाँ, हर्ष को बोल.
वो चला गया अपने रूम पे.
Then who is the second one who is shouting?
प्रथमेश यादव DCR.
अच्छा. See, don't do all these nuisance in my class. ऐसे नहीं है, online नहीं चलेगा. You will be there in my class for offline also. है ना? So it will be very, very tough for you then. Keep in your mind, मेरे class में ये सब चलेगा नहीं, बिल्कुल नहीं चलेगा. 1000 doubts you ask, I am for that. But if you'll do all these nonsense things, right? See, from last 22 years, I am here in this field. Here means not in Tolani, but in all in teaching field. Right? 22 nahi to chalo 18 years to pakka pakad ke chalo. Because I worked somewhere in industry before that. है ना? So I know what not things you can do. मेरे भी बच्चे हैं, so I know what they used to do. But I am having solution for all these things, and I can do. I can go directly to principal sir and complaint related to this division, and then you will keep on getting punishment. I don't want. I am least interested in all these things. बिल्कुल मेरा interest नहीं है. You are forcing me to do. Don't force me to do some negative things. Right? I always like to do positive, जिससे energy increase होगा हर एक का. This will only cause a chaos, nothing else. So जो focused है उनको focus रहने दो. And it's my request. Okay, I'm requesting. Last time. An armature. Sorry का मतलब जानता है? Sorry का मतलब जानता है क्या? अरे who said sorry? Who said sorry? Who said? Loudly.
मैंने बोला था.
आप क्यों बोल रहे हैं? आपने कुछ किया नहीं है तो. Then what is the logic? छोड़ दे.
मेरे माइक से डिस्टरबेंस हो रही तो इस वजह से.
छोड़ दे. ये आपकी प्रॉब्लम ही नहीं है. You should not say sorry for someone's mistake, है ना? छोड़. An armature has a resistance keep in your mind, we are in this world for learning, and it's not learning means technical learning. Many other things are there to learn, and you are just 17, 18, 19 years boys, right? Boys or girls. Don't waste your energy in all these bakwas things. Try to learn new things. Many things are there to learn, and you may think, ये मुझे क्यों ये क्यों चाहिए मुझे? इससे क्या मेरा फायदा? You don't know. You don't know which thing you have learned, right? in your childhood, now you will find yes how it will be useful. So you don't know what is going to be there in आपके थाली में क्या परोसा जाएगा कल परसों. You don't know. कल परसों मतलब कल परसों नहीं, in your future. तो इट्स वेरी नाइस. आपका एज है, एनर्जी है, एंथुजियाज्म है, इस सबको ना अच्छी तरीके से कल्टीवेट करो. डोंट गिव नेगेटिव डायरेक्शन टू दैट. दैट इज नॉट गोइंग टू हेल्प यू. दैट विल ओनली create a problems for you, nothing else. That is मुझे लगा ऐसे मुझे बोलना चाहिए, भाषण नहीं देना है, but I feel I should tell you, so I told you. Fine. We'll go for the technical things now. An armature has a resistance of 0.2 ohm at 150 degrees centigrade and the armature copper loss मतलब I square R. The power which is getting which is acting like a loss, so I square R it is. Okay, copper loss is to be limited to 600 watt. 600 watt with a temperature rise of 55 degrees centigrade. If alpha naught for Cu is 0.0043 per degree centigrade, what is the maximum current that can be passed through the armature. ठीक है? So I have given you the numerical and you please solve it. And tell me the answer. I'll wait for 3-4 minutes. Type your answers in the chat box. कर रहे हो आप?
Yes, ma'am. Trying.
Yeah, करो. Very good. Just I ensure कि आप कर रहे हो ना, बस बाकी कुछ नहीं. चलो किसी ने किया ओके 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 स्लाइटली डेविएटेड एक मिनट बहुत सारे आंसर आ गए भरत इज रॉन्ग देन जितेश इज रॉन्ग try to see what is wrong huh then 53 correct Dev you did it correctly but your answer is deviated from the actual answer might be while like point not something right
How much deviated? Because I took something approximate. That's why.
That's what I'm saying. So don't do that. No, why you are doing that? Don't do that.
Okay.
Take exact thing. Why? Small change in the current. If you say I got 3 ampere and you got 1 ampere, you say 2 ampere ka difference, but 2 ampere is a large number because normally
I'll try to solve it actually.
Correct. Jatin, it's wrong. Bharat, again, it's wrong. Okay. I think I should solve now. Or you want me to wait? You just tell me.
Just a second. Just a second.
Fine. I'll wait. Jatin and Bharat, again you try to solve the thing. Might be somewhere you plus ka minus something. No, Bharat, still it is wrong. Out of all, right, only one student got the answer near to the actual answer. No one else. Check it. Check it once. Now it's best. Yeah, absolutely. Good enough. Correct hai. So one student gave me correct answer. That is Dev. Bharat, now you are nearer to the answer again, but you have done approximation and because of that, जैसे मैं लिखूँ ना 0.038 तो आपने 8 निकाल दिया 3 लिया तो your answer is deviated है ना तो ठीक है कोई बात नहीं but it will be better if you take actual one क्योंकि एग्जाम में ऐसे करोगे तो it will be a problem for you. Just wait for 1 second. Yeah. So the thing is given is, I'll write now. Just a moment. Answer. First thing is you are supposed to get the current. You know the power. So P is equal to 600 watt. You know the formula for that. That is I square R. Right. And what is this R at what temperature it is? This is, I mean, at what temperature the wattage should not be, copper loss should not be 600 watt. That is a rise of temperature, rise of 55. That means this condition we are talking here about for kya hai initial 150. Yeah. 150 and plus rise 55. That means we are talking. अरे मैंने degree लिखा. 1 minute. So what he is saying? 205, 150 plus 55. Absolutely correct. 150 plus 55, and that is at 205. Right? जिनके बहुत ज्यादा दूर आंसर आए हैं, मतलब far away from the actual one, definitely instead of adding it, you might have just considered 55 over here. यही problem हो सकता है, what I feel. So this is at 200. So what I'm supposed to do now? I'm interested in, I want to know the current. I'm interested in this resistance. So that means T2 ka value, if I'll say 205, correct? At that point, whatever will be your RT2, we want to calculate that. And the another condition is given, that is T1, which is 150 degrees centigrade. And at that point, your RT1 is given to you. And how much it is? 0.20. And alpha naught is also given to you. That is 0.0043 per degree centigrade. So what you are supposed to do? RT1 by RT2 upon 1 plus alpha naught T1 by 1 plus alpha naught T2. Right? So RT1 is 0.2. RT2 you want to calculate. 1 plus 0.0043 into T1. T1 is 150. And 1 plus 0.0043 into 205. That's it. So now you tell me RT2. Calculate this thing and tell me this value. I'm waiting for your calculations. Either put it in the chat box or you tell me over here. No problem.
0.22 ma'am.
See now you are approximating again. They 0.2288. At least you take 0.229. At least your answer should be correct till 3 decimal places when you are talking about electricity. Why I'll tell you. When you are saying I got 1 ampere and another student got 3 ampere, there is difference of 2 ampere only. But this 2 ampere means 2000 milliampere. If the difference is in milliampere, that is okay. That is not going to affect your circuit that much. But if it is in amperes, it's a large value. So that's why small change in this R is going to affect value of I largely. That's why. आप करके देखो आपको समझ में आएगा. ये 49 वाला है ना भरत, इसने यही किया होगा. So now 600 is equal to I square and 0.2288. So can you tell me I का value?
51.29.
51.209 ampere. Correct. Chalo. So we have finished with the numerical. Any of you, any query, any doubt? Yes, कौन था? एक मिनट. हाँ. Jitesh, is it okay, Jitesh? Jitesh, is it okay?
Okay, sir. Ma'am.
Okay. And Jatin, is it okay? Jatin?
Yes, ma'am. Yes, ma'am.
Yeah, good enough.
Ma'am, why did you add that 150 plus 55?
Because you read the numerical. It is given that
It is
600.
loss written, ma'am.
Huh?
It's written that loss.
No, loss is okay. Loss is the copper loss. Copper loss means I square R loss. See, whenever current is passing through the resistance, it's get heated up. Whenever heating is there, that is loss to your system. How much heating loss is going to be there in the winding? It is I square R. That's why it is called as copper loss, because normally the windings that we are having are made up of copper. So we used to say it is copper loss to the system. Power is getting wasted, right? But you read this thing, 600 watt with a temperature rise of 55. That means previously it was 150 and there is rise of 55 in the temperature and it is becoming 205. Have you got?
Yes, ma'am.
Yeah, done. Chalo, good enough. So that's it. And it's already 50. So I'll stop over here because now next lecture onwards we'll go for more numericals, because what is there now? Series, parallel, Ohm's law and the theorems. And I just like those topics. Hai na? So more numericals and less theory part. So we'll start with that thing in the next lecture. Okay? Chalo, I'll clear the board. Is it okay? I'll clear the board, everyone?
Yes, ma'am.
Yeah. Just a minute. Huh? Yeah. So it's division 2. Belgaonkar, Abhishek.
Yes, ma'am.
Abhishek, you are from Belgaon or?
No, ma'am. Pune.
Achha, you are from Pune, but you are Belgaonkar. Okay. Ranak? Ranak, you are there, 43. Bharat? Bharat hai. Bhuvan? Yeah, I know. Bhuvan? Bhuvan, you are there. Chaitanya? Chaitanya? 46. Daksh? 48. Daksh? CR, you keep on noting these numbers. These students are not giving attendance, right? Unnecessarily they are getting marked absent. I can't help because just they are there in the participant list. I will not give attendance to them. They have to say yes, ma'am, if they are there in the class. If they are not going to say, I'm going to mark them absent. Simple. Darshan? Darshan, you are there? Dev? 52. You are able to hear me? Yes?
Yes, ma'am, you are audible.
I am audible, but they are not responding. Okay, Dev was there. Yeah, he gave the answer. Devansh?
Yes, ma'am.
Yeah. 55, Devansh? Yeah, I marked you. Dev, I marked you present.
No, ma'am. Devansh Tandon is also with me, ma'am.
Devansh Tandon. Okay.
Hello, ma'am. Hello, ma'am.
एक मिनट 54 पहले बोले.
Yes, ma'am. Devansh was 54.
Is there. Okay, then Devansh Tandon is there. हाँ बोल.
45.
एक मिनट. Listen. The number which already मैंने ले लिए वो एंड में बात करेंगे अभी मुझसे. I just want to talk with now. Devish is there. Is there Devish in the class? No. Dev? 58. Dhruvo? Dhruvo, you are there? 59. Dhruv? Tyagi?
Present, ma'am.
Good, yeah. Dhruv Kakde?
Present, ma'am.
Okay. Then Dishant?
Present, ma'am.
Okay.
Ma'am, Daksh Bhargava was present.
दक्ष का नंबर क्या है?
Ma'am, 48048.
बाद में हाँ गया ऊपर गया है तो बाद में रिमाइंड किया.
Yes.
Animesh is the CR, right?
Yes, ma'am. Actually, he's gone to washroom.
Okay, ठीक है. Gaurav 66. Harsh Sharma.
Present, ma'am.
Harsh Yadav
Ma'am, Harsh Yadav is with me.
is with you. Okay.
Yes.
Manthan is there. Himanshu?
Yes, ma'am.
Yeah. Himanshu, you are there? Punardeep?
Present, ma'am.
Yeah. Indrayan. Indrayan. Prathamesh Jadhav. Ha, he's there. Yeah. Yeah, okay. Jeffy. 79, Jeffy, you are there.
Is in the toilet, ma'am.
Sahil. हाँ साहिल is
Present,
there.
ma'am.
Yeah. Then अरे दो जगताप साहिल है क्या?
हाँ मैम, दो है.
तो सीआर कौन सा है इसमें से? नहीं, सीआर कोई भी नहीं है. Okay, दोनों सीआर, दोनों साहिल are there. Okay, fine, done.
Excuse me, ma'am.
Yes.
Himanshu Anna is present, ma'am.
Kakade also present. Ma'am.
हाँ. बोलो.
Excuse me, ma'am. I'm Indranti now. Ma'am, Dhiru Kakade also present. Ma'am, Dev John.
हो गया सबका बोल के. Now I'll take the attendance. You have, if you want attendance, you have to tell me in the last. Okay. Then Jagtap Sanket.
Present, ma'am.
Yeah. Jatin.
Present, ma'am.
Yeah, Jitesh is there. Yeah, I know. Yeah, because you answered the thing. And Prasad.
Present, ma'am.
Yeah. Again, I'll take the numbers. Right, the one who I marked absent. If you are there, just say yes. Jeffy, you are there. Indrayan is there.
Yes, ma'am, I'm here.
Okay. Then Gaurav.
Yes, ma'am, I'm there.
Okay. Then Dhruvo. Dave.
Yes, ma'am.
Yeah. Devish.
Jaffe is present, ma'am. He's gone in the washroom, ma'am.
Let him come and he'll give the attendance. Okay.
Okay, ma'am.
Yes. Dev Bharadwaj.
Present, ma'am.
Darshan.
Yeah, ma'am. Darshan is present. Actually, the land is not working, so he's sitting with me.
Dhruv Kakade gave his attendance. So, Dhruv Kakade, you are giving whose attendance?
Yes.
Huh?
Actually, ma'am, was sitting with me, Dev and Darshan. Ma'am, Darshan, ma'am, me.
What? Repeat. Darshan, you are there? 4-9.
Yes,
Yeah. Okay. Daksh.
Present, ma'am.
Chaitanya. And 1.
Present, ma'am.
And Ranak. Now I don't understand why you are sitting together. First thing.
Ma'am, LAN cable, it's not
अभी तो
working.
चल रहा है. Just now I talked with IT and IT saying all are working very nicely now.
मैम कभी कभार नहीं चल पाता, कनेक्ट नहीं होता, पता नहीं क्या होता है. एक रूम में अगर 2 LAN है तो एक ही चलता है कभी कभार.
79. I am at admin block for 78. Okay. Chalo, all the best everyone.
Thank you, ma'am.
All the best.